From Boston to Washington, D.C., the East Coast is famously crowded, a near-continuous ribbon of cities and suburbs. It's the most densely populated region in the entire country. So why is there this huge, anomalous gap? A stretch of coastline that looks like it should be full of development, but simply isn't. All the ingredients for growth are here. You're still just a short drive from major cities. You have miles of beautiful sandy coastline. You get warm summers and mild winters. It seems like a developer's dream. But this land holds a secret, one written into its very geography. It's not empty land, it's difficult land. This is a landscape that actively resists dense, permanent settlement, and in this video, we'll find out why. Two questions explain almost everything. First, what physical stop signs does this landscape put in your way? Second, how did history and infrastructure steer growth away from here and keep it there? Here's the proof in one look. Much of this coastline is low, wet, and always negotiating with water. Think of the East Coast like two parallel worlds. The first world is slightly higher and easier to connect. So highways, rail, and job centers line up there like beads on a string. The second world is the Atlantic edge. Barrier islands, sounds, bays, marshes, and flatland that holds water. And the key difference isn't politics or preference. It's drainage. Dense cities are machines made of infrastructure. Pipes, power, roads, and storm systems that have to work every single day. Infrastructure loves stable ground, but here, the ground can behave like a sponge. The first constraint is the water table, often close enough to the surface that digging down means hitting water fast. That affects foundations, basements, septic systems, and anything you want buried underground. And even when you solve it, you don't solve it once. You solve it every season, every storm, every year. Roads show this problem perfectly, because roads aren't just asphalt. Roads need a solid base, and on wet land that base is expensive. If you skip steps, the ground reminds you. Now add the second constraint. The coastline itself isn't fixed. Barrier islands are long sandbars that shift over time. They protect the mainland like a shield, but they also move, erode, and sometimes break during major storms. That means build here can quietly turn into rebuild here. And there's a third constraint hiding inside the map: geometry. On land, we build in straight lines, imposing a grid for efficiency. But water doesn't follow our rules. It carves its own path, and in doing so, it breaks the grid. In a typical city, the street network is a predictable matrix. You can go 3 blocks east, 2 blocks north, and you're there. Travel is direct, and distances are easy to estimate. But in a watery coastal plain, that logic dissolves. You might need to drive 15 minutes around a creek that looks tiny on a map, turning a short straight line into a long, winding journey. Instead of one connected street network, you get isolated pockets of settlement separated by water. Each community becomes an island, functionally if not literally. And every time you connect these pockets, you need expensive bridges and causeways. These structures become critical lifelines, but also vulnerable choke points for entire regions. Bridges are lifelines, and they're choke points. They're expensive to build, expensive to maintain, and vulnerable during storms. So when people ask, why isn't this coastline packed? Start here. The land doesn't invite dense permanence. It charges you for it. And yes, people live here, and many towns are thriving, but the landscape rewards space and punishes heavy, interconnected systems. That's the first payoff. The blank space isn't waiting for a city. It's a place where nature sets terms. Now let's talk about the second half of the story: routes. Early American growth didn't just chase coastline, it chased dependable harbors and reliable paths inland. Some coastal waters are shallow, wide, and constantly shifting with sand. That can be beautiful, but it's tricky for the kind of deep, predictable channels that big industrial ports love. For centuries, the most important economic hubs formed where deep-water ports met the shore, places where ships could reliably reach and goods could easily leave. These coastal cities became the engines of trade, connecting continents. But the next wave of transportation technology would fundamentally reshape the landscape just beyond the docks. Then railroads arrived. Rail is a technology of brute force efficiency, and it loves two things: straight lines and firm ground. Steel wheels on steel rails demand gentle curves and stable foundations to move heavy loads safely and economically. For railway engineers, coastal wetlands and meandering waterways were a nightmare. They meant expensive bridges, unstable soft ground requiring deep pilings, and a budget for constant, costly maintenance against water and weather. So, rail networks naturally hugged slightly higher, drier corridors just inland, bypassing the soggy coastline. Decades later, highways doubled down on the exact same logic, because asphalt and concrete also hate surprise water. This created a clear pattern of inland infrastructure that persists to this day. Once the main arteries and the main job hubs form inland, they reinforce each other. Jobs pull people. People justify infrastructure. Infrastructure attracts more jobs. It's a growth loop, and it's hard to break once it's established. Quick pause. If you like this map first geography logic, subscribe for more. Now bring it to the present, because modern life has even stricter requirements than railroads did. The biggest limiter today isn't beauty, it's the cost of making daily life work at scale. When homes are spread out, everything costs more. Schools, hospitals, emergency response, water lines, internet. A dense city spreads one big system across millions of people. A scattered region pays per mile, again and again, and storms turn choke points into real problems. Even a short closure can turn a normal commute into a major reroute. Low elevation also means you're always thinking about flooding, where water goes and how fast it leaves. That pushes building costs up. Higher foundations, stronger codes, more drainage. Over time, insurance and rebuilding can turn cheap land into expensive living. Big employers also want reliable connections, airports, logistics hubs, dense networks. If your landscape is a maze of waterways and flood zones, connectivity becomes the bottleneck. One more twist. A lot of the land here is protected on purpose. Wetlands aren't empty space. They buffer storm surge, filter water, and support ecosystems, so development gets restricted or pushed onto narrow strips of higher ground. That's the second payoff. Modern growth doesn't just need land. It needs cheap, reliable connections. And this landscape makes those connections hard. And then there's identity. Many coastal communities grew around fishing, boating, forestry, farming, and tourism. Those can be strong economies, just not always built for year-round big city density. In many places, the extra housing isn't apartments, it's second homes, so the region can feel quiet on a Tuesday and packed on a holiday weekend. The twist is this: it's not a failed place. It's a landscape designed for space, where water and nature still get a vote, so that huge empty stretch of the East Coast isn't empty by accident. The land is low and wet, the coastline shifts, water breaks the grid. History routed rail and highways toward higher, cheaper corridors, and modern life rewards fast, reliable connections and lower risk. Now I'm curious, what do you think is the biggest reason? Water, routes, or risk? And next time you see a blank stretch of coastline, remember, the map isn't showing emptiness, it's showing constraints.